Namaste everyone. Welcome to second PU physics class. We were discussing about different formulas and power dissipated, LC oscillations, transformers, etc. So almost that completes that chapter, except a few derivations I didn't do. One is derivation of Z. Whatever I have done already, the derivation of Z, that is very important. That is needed for the exam. But whatever I do now is in the syllabus, but it will most of the times it is not asked for the exam. But still I will do that so that it will be helpful for the students who are seriously preparing for entrance examinations. Maybe some part of the circuit may give some ideas to them. Okay, analytical method. We are using some trigonometric functions and analytically we are treating it, an analytical method of deriving Z, phase difference between current and voltage in a series resonance circuit. Analytical method or analytical solution. Alright, that is better. Analytical solution for the phase difference between current and voltage in a resonance circuit. Of course, I need the full board now. We will start from the series resonance circuit. You know that in a series resonance circuit, of course I don't draw the circuit. We have the equation for current and equation for the voltage. V is equal to Vm sin omega t. I don't know what is the equation for the current. That is what I have to derive. Using a phasor diagram, we have done that. We know that it is I is equal to Im sin omega t plus phi. Phi is the phase difference. And with all those knowledges, we will see how to do it mathematically now. Now, and you know that in a resonance circuit, okay, I need a circuit now. Resistor, a capacitor and an inductor. We have these things. R, C and L. Now, the voltage across V is equal to Vm sin omega t is the applied voltage. Now this V will appear across R, C and L. Of course, total voltage is not numerical sum. If you put numerical sum, you will get different answer. It may not be so because they are not in phase. Voltage across inductor, voltage across capacitor are not in phase. Even across resistor is not in phase with the voltage across inductor and capacitor. All the voltages individually they are in different phase. So I will take an equation for charge because charges will be flowing in the circuit. Charges will be stored in the capacitor, there will be current through the inductor, there will be current in the resistor. And if you write the equation for this V, Vm sin omega t, what it is equal to, that Vm sin omega t should appear as voltage across resistor, voltage across capacitor and voltage across inductor. How do they appear? Across the resistor it appears as IR, am I right? And across the inductor it appears as L di by dt, am I right? Voltage across inductor it is L di by dt, voltage across resistor is IR. What is about capacitor? Q equal to CV, you know the formula. What is V? Q by C. So I will use a small letter q here, Q by C. Am I right? That voltage which is supplied at any instant, that is Vm sin omega t, according to the formula that it will be some instantaneous value, this value, that must be in the form of IR across R, must be in the form of L di by dt, that voltage across L, and the same voltage, the remaining voltage should appear across C in the form of Q by C. Now let us assume an equation for Q. Let Q is equal to Qm sin omega t plus theta, because we don't know the phase difference between charge and voltage. You know that even in the individual components like a capacitor and inductor, current will not be in phase with the voltage. When the current is not in phase with the voltage, definitely the flow of charge, the amount of charge flowing is also not in phase with the voltage. Let theta be the phase difference. Q is equal to Qm sin omega t. If Q is Qm sin omega t, then what is I and what is di by dt? We have to substitute it here. I is nothing but dq by dt, right? That is, you differentiate this. I think I need not spend the space for differentiation. Qm sin omega t plus theta. This is the function of time which has to be differentiated. Qm omega, because differentiation of omega t is omega, cos omega t plus theta. Am I right? Qm omega cos omega t plus theta, or Qm cos omega t plus theta, differentiation of omega t is omega. What about di by dt? Because we want to substitute for I here also, di by dt. Di by dt is the second differentiation of this, d squared q by dt squared that is equal to qm, this becomes qm omega. Differentiation of cos omega t is minus sin omega t plus theta, and again differentiation of omega t, omega square. That is omega, right? Hope you have followed these differentiations. Q is equal to qm sin omega t plus theta, that is assumed one equation, and I is equal to dq by dt, d by dt of qm sin omega t plus theta, that is equal to qm omega sin omega t plus theta, cos omega t plus theta. Differentiation of sin omega t plus theta is cos, and differentiation of omega t is omega. Di by dt is differentiation of this qm omega constants. Cos omega t plus theta is minus sin omega t plus theta. Differentiation of omega t is another omega, which makes this omega square. Substitute all these equations in this one. Vm sin omega t is equal to, that is applied voltage, should appear as IR. What is IR? Qm omega R. R I have introduced here, cos omega t plus theta. Cos omega t plus theta plus L di by dt. L, of course you have minus here, right? You see, automatically you have got minus because induced EMF across an inductor is minus L di by dt. So L di by dt, you have got it as negative. Where is it? Yeah, this one. Di by dt, differentiation of q second time, and qm omega square. L qm omega square sin omega t plus theta. Sin omega t plus theta. Okay, so we will move on now. Right, shall I write one more step here? I think you can see it. Right. Vm sin omega t, Vm sin omega t is equal to, shall I take qm omega? One more thing we have not finished, right? Across inductor we have written, across capacitor we have not written. This is over, this is not over. Q by C plus Q is nothing but qm sin omega t, right? Qm sin omega t plus theta. Qm sin omega t plus theta and by C. Am I right? So Vm sin omega t is equal to IR. I is qm omega cos omega t plus theta. Qm omega cos omega t plus theta into R. Minus because L di by dt is L. Di by dt is negative, that's why minus qm omega square sin omega t plus theta. This was remaining. Plus Q is qm sin omega t plus theta. Qm sin omega t plus theta by C. That is over. Okay, what is Vm sin omega t? Vm sin omega t is equal to, I need more chalk now. Vm sin omega t is equal to qm omega, I can take it outside. Of course, here I don't have omega. That's why I multiply and divide by omega. So when I go for next and next steps, you will come to know why those steps are followed. Because I want to bring XL, XC, phi and everything. Finally, I want to know what is the phase difference between current and voltage. Multiply and divide by omega here. That is the extra thing that we can do. Now qm omega, and here you have an extra omega also. So we will take qm omega outside. Okay, inside the bracket, what you will have? Qm omega R cos omega t plus theta. R cos omega t plus theta. Okay, R cos omega t plus theta. What else? Qm omega, and here qm omega is taken out. Minus L omega or minus omega L sin omega t plus theta. Okay, minus omega L sin omega t plus theta. What else? Here qm omega is taken out. 1 by omega c. I think you will understand why did I got qm omega out. See, omega L, omega c, they are all XL and XC. Sin omega t plus theta. Sin omega t plus theta. Yes. Okay. So shall I replace this as XL? Shall I replace this as XC? Definitely. Then what I will get? No, this totally as XC, right? 1 by omega c itself is XC. I can replace them. What else I will get? Vm sin omega t minus qm omega, okay, c, R cos omega t plus theta minus XL, because XL is omega L, sin omega t plus theta plus XC sine omega t plus theta. See, this can also be clubbed. Which one? This one and this one, because sine omega t plus theta is common. xc minus xl. Now you see, you are getting the same things what did you do in the phasor diagram. Okay, Vm sine omega t is equal to here qm omega into r cos omega t plus theta minus or plus xc first minus xl, common. Sine omega t plus theta is common. Yes. Now let us take z and multiply and divide by z. Let z, here to assume it here, let z is equal to root of r square plus xc minus xl whole square, and multiply and divide by z now, and okay, what you will get? Vm sine omega t is equal to qm omega into, okay, multiply and divide by z. So if I multiply and divide by z here, what I will get? I will get, and multiplied z, I will put it outside. Multiplied z here, divided z here. I think it is okay now, right? That is extra thing I do. Multiply and divide by z. So z into z by z into z by z. So z will come outside into. Let this r by z. See, the reason for doing like this is, you can take r by z as something like cos phi, xc minus xl by z as sin phi. Then the equation turns into some form in the trigonometry. Cos phi cos omega t plus theta, sin phi sin omega t plus theta. Can you get it? So let z equal to this much and cos phi is equal to r by z, and this is the sin phi is equal to xc minus xl by z, and tan phi is the ratio of these two, right? R by z, sin phi by cos phi, that is xc minus xl by z into z by r, that is xc minus xl by r. Okay, so qm omega z into r by z cos phi, because we have substituted this as cos phi, and cos omega t plus theta plus xc minus xl, that is by z, that is equal to sin phi, okay, sin phi sin omega t plus theta, right? Now can you reduce this? That is why I have taken this as r by z and replaced it as cos phi, and this is sin phi. Cos a cos b plus sin a sin b, right? It is cos a minus b, right? You can write it like this. Vm, next step becomes Vm sin omega t is equal to qm omega z into, this can be written as cos omega t plus theta minus phi. If you write it like this, okay, square bracket here, cos omega t plus theta minus phi, cos a cos b minus sin a sin b, right? This can be written as a, or this is b, say this is b and this is a. Cos a cos b plus sin a sin b, right? Cos a minus b, cos a cos b minus plus sin a sin b, cos a cos phi, cos b omega t plus theta, sin a sin phi sin omega t plus theta sin b. So that is over. Cos omega t plus theta minus phi. Okay, now if you compare this with sine, here you have sine and here you have cos. So you will write it like this. Vm sin omega t is equal to qm omega z into sine, because sin 90 plus theta is cos theta, sine omega t plus theta minus plus pi by 2, sorry, minus phi plus pi by 2, sine omega t plus theta sine omega t plus theta minus phi plus pi by 2. Take this as simply x. cos simply this much as x, cos x is sine 90 plus x, sine 90 plus x, omega t plus theta minus phi. Okay. Now you can compare Vm sine omega t, this sine omega. Okay, shall I rub some of the part here? I think I can rub this part because this is not needed now. Intermediate steps. Okay, I'll write it here. Oh, this is needed. This substitution is very much needed. Let z is equal to root of r square plus xc minus xl whole square, and cos phi, you know this however, r by z, and sin phi is equal to this much, tan phi is equal to xc minus xl by r. That is needed. Okay. Right. Now if you take this equation, Vm sine omega t is equal to Qm omega z into cos omega t plus theta minus phi plus, sine omega t, sine omega t plus theta minus phi plus pi by 2. Yes. Right. What else you'll get? So in the place of Vm, you have Qm omega z. So Vm is equal to Qm omega z. If Vm is equal to Qm omega z, Vm by, so shall I write what is Vm is equal to Qm omega z. Vm by z I'll write, because you know that it is Im. Vm by z, peak value of voltage divided by total impedance, that is Im, that is equal to what is Vm by z, that is Qm omega. So we have got one equation. Vm by z is Im, that is Qm omega. Okay. What else we get? Comparing this part, this and this, omega t is equal to omega t plus theta minus phi plus pi by 2. Right? So I will take it as omega t plus phi, because finally I should get equation for current I is equal to Im sine omega t plus phi, right? Plus phi, because V equal to Vm sine omega t is applied voltage. I want to get a current I equal to Im sine omega t plus phi. So I'll bring this phi here. What I'll get? Omega t plus phi is equal to omega t plus theta plus pi by 2. Am I right? Okay. That is obtained. Now what else I want? Shall I rub, this is needed, this is very much needed. I want to rub something else now. I think these two steps can be rubbed. This is needed, but this is not needed, because that is an intermediate step, that's all. So this is written already. Yeah. Now, if you take the equation for current, this one, directly here, I is equal to Qm omega cos omega t plus theta, right? So if I write, what is Qm omega? Qm omega can be written as Im, Vm by z. So what I'll get? I is equal to Im, because this is what is your aim now, to get the equation for current. I is equal to Qm omega Im cos omega t plus theta. Express this in sine. I is equal to Im sine omega t plus theta plus pi by 2. But you see, what is omega t plus theta plus pi by 2? That is omega t plus phi. So I is equal to Im sine omega t plus phi. You see how beautifully we have got it. But in phasor diagram method, it was much easier, so we got it very easily, the phase difference between current and voltage. So this is analytical method, right? You are using all the mathematical equations and substituting some values here, so that we will get a trigonometric function, then analyzing it. So I is equal to Im sine omega t plus phi. This equation shows that current leads the voltage by or current and voltages have a phase difference of phi, and that phi is given by either tan phi is equal to xc minus xl by r, or this one sin phi is equal to xc minus xl by z, or cos phi is equal to r by z. Any equation will give you the phase difference, and if phi is positive, current leads. If phi is negative, current lags. That is the final ending. Hope you have followed this lengthy method, but this will not be asked for exam. Analytical method. You will be asked to derive the equation for current and z or tan phi, anything. using phasor diagram method. Thanks for watching this class. We will meet in the next class with few more derivations. Thank you.